I'm going to explain how to solve quiz 2 of electricity and magnetism. And it says like this. 4 point charges are placed at the following x and y coordinates. The first one, the charge 1, is placed at minus 3 centimeters, comma 0. Charge 2, that is this one, is placed at plus 3 in x and 0 in y. The charge 3 is placed here in the origin, and the charge 4 is placed here in minus 2 in y and 0 in x. This first charge has a charge of minus 1 microcoulomb. The second charge has minus 1 microcoulomb as well. The charge 3 has plus 1.024 microcoulombs, and the last one has the charge of 2 microcoulombs. We have to calculate the net force on charge Q4 due to the points 1, 2, and 3. Okay, so this is our main charge. First of all, we have to notice the distances between the charges. So here we have one distance, here we have other distance, and here we have other distance. This first distance will be the distance r from 1 to 4. This one here is going to be the r from 3 to 4, and this one here will be the r from 2 to 4. Once we notice the distances, we can calculate how the forces are acting here. I'm gonna draw it right here for more detail. We have here our charge 4, that is our main charge. Once we have our force 4, we can draw here the force from 2 to 4, that is this one. And as they are different signs of the charge, the force goes to the other charge. But here in the third charge, they both are positive. So the charge goes downwards. Here is the force 3, and its force from 3 to 4. And here finally we have the other force, that it's minus and plus, so it goes to Q1. Here we have Q1, and it's the force from 1 to 4. Okay? Now we have the drawing of how the forces act. Here we have our x and our y. As we can see here, we have this one and this one. We will have to divide it into the x and the y force. But if we look to the x force that creates here and the other x force that creates here, we can notice that the charge 1 and the charge 2 are exactly the same. So the x forces cancel each other. So we will have 0 forces, that the total force will be equal to 0. But we notice that here in the y we will have these two here, that both components, and this one. So we will have here a total force in y. Okay? Once we notice this, we can do the explanation of the total forces in y. The total forces in y are represented first with the force of 1 to 4 that goes upwards. So we will have the force of 1 to 4 that it's multiplying. Here we will have the angle that is exactly the same as here. Okay, this is the angle. And as we are talking of the y-axis, and we have theta here, we are talking of the cosine of theta. So we will multiply this by the cosine of theta. Then we will add the force 2, 4 in the y-axis, 2, 4. Well, we won't be talking about vector. Cosine theta, because it's exactly the same as in this part, but with this part, minus the force that goes downwards. Okay, the force that goes downwards is the force from 3 to 4. This. Now we can get to know the forces, but we know that the force is equal to the constant times Q1, Q2 over R2. Okay? Once we know this, we have these values right here. So we only have to substitute. So this will be exactly the same as the constant in Q1. It will be the absolute value, because we are just looking for the force, not the vector itself with magnitude and direction. This will be over R1 to 4, that we have it right here, plus the constant of Q2 times Q4 over the R from 2 to 4 square minus absolute for charge Q3 plus charge 4, and this divided from 3 to 4. Okay. With this equation, what we can notice is that, as we say right here, our charge 1 will be exactly the same as the charge 2. Once we notice this, we can notice that this part here will be exactly the same as this part here. Even though this is R from 1 to 4, for here it goes to 4. Okay. 1 to 4 and 2 to 4, the distance from this charge to this charge and this one to this one will be exactly the same. For taking that value, we will draw here the triangle, and we know that this size will be equal to 3 and this size will be equal to 4. So if we have here the square root of 3 squared plus 4 squared, this will be equal to 5. So the distance in here and in here will be equal to 5. This part, I'm gonna write it here. This part will be equal to the constant, because the constant is in the 3 ones, and the charge 4 is also in the 3 parts. So we can get them out. The constant times the charge 4 multiplies 2 times the charge 1 times the charge 4, because we said that these both were exactly the same, times the cosine of theta, because is this part of here, over the R1 to 4 square, that we say that this value is equal to 5 squared. Okay? And this will with this part, we only have to subtract the part of the force that goes downwards. So this part is the charge 3, because we already have here the constant, and charge 4 over R from 3 to 4 square, and this will be exactly the same as 4, because it is said at the beginning of the problem. Once we have this, we have the value of the charge 3, and we have the value of charge 1 and the value of charge 4. So I'm going to write here how it will end. The k, the constant k, is 9 times 10 to the 9. The charge 4 it's exactly 2 coulombs, 2 microcoulombs. And this part will be multiplied by 2 times the charge 1 times the here we don't have to put this one because it is already here. So we only multiply 2 times the charge 1 times the cosine of theta. Here we have theta, so the cosine of theta will be equal to the adjacent over the hypotenuse, that is 5. Okay, so here we put 4/5. This over here, it is given in meters, so we have to convert this into centimeters. 0.05 squared minus 1.024 over 0.04, this one 2 centimeters squared. And if we consider the values of these two parts, this will be 16 over 25 minus 16 over 25, that this is equal to 0. So the total force, it's 0 in x and 0 in y, so the total force, it's equal to 0.